Scale AI was awarded a $250 million contract by the Department of Defense and the Joint Artificial Intelligence Center. Scale AI focuses primarily on data management for AI applications, but also does work in image analysis, general autonomy, and natural language processing. The company has scooped up several former federal employees in an effort to get more of this work. Whether you love it or hate it, DARPA has historically been a major contributor to AI research in the United States, and investments like this from the DoD will have an impact on future developments. Antibodies play a critical role in our fight against viruses. When it comes to developing synthetic antibodies, researchers have to figure out how to fit proteins together in just the right way. The problem is proteins are complex structures and there's often millions of different combinations that proteins can take. So how do we figure out which one is the right combination? This turns out to be an excellent use case for some AI. Machine learning can now predict the correct complex where the proteins bind together, which is estimated to be 80 to 500 times faster than current state-of-the-art methods, and in some cases demonstrates superior fidelity to actual experimental results. OpenAI has published a new entry in their GPT family called InstructGPT. As you might guess, the main adaptation here is that InstructGPT is way better at following user instructions. The main technical adaptation here is that it was trained with humans in the loop using reinforcement learning from human feedback. In effect, they took submissions to their language API and had humans label these examples, which were used to fine-tune the model. The model also only has 1.3 billion parameters, which might sound like a lot until you consider that GPT-3 had some 175 billion parameters, so it's much smaller and lighter. The model is not only better at doing what people say, it is also more truthful and less toxic. This is because GPT-3 has a nasty habit of making up facts and in some cases generating quite explicit material when it had nothing to do with the original prompt. Still, I think we can all agree, even being slightly less toxic when you were trained on the internet itself is kind of a miracle. I mean, how do you do that? The next story is another one from OpenAI. This one is super useful, which is why I'm highlighting it. I'll be using it in my own projects very soon. OpenAI has leveraged their work in GPT-3 and other language models to bring us a general way to embed our word vectors in a useful space. So for example, word search in such a space generally works better if words that mean something similar live close together, and moving in any given direction around the word says something about the word. So the dimensions of the space are representative of the words in the space. They have released 3 general variants of this model: text similarity, text search, and code search. In their overview, they cite a very cool use case where these embeddings have been used to make searching astronomical records much easier for researchers. A very interesting publication was made available this week called Natural Language Descriptions of Deep Visual Features. These researchers describe a method that automatically annotates learned features and image data using mutual information guided linguistic annotation of neurons. That's quite a mouthful. They just call it Milan. The link to the paper is in the description, but the basic idea is to generate a description by quote, searching for a natural language string that maximizes point-wise mutual information with the image regions in which the neuron is active. In other words, we use a convolutional neural network. This is the kind of network that often gets used in computer vision, and allow it to encode high-level semantic information about a particular scene. We also hand label fine-grained image annotations, or as the paper calls them, melanotations. It's all one, melanotations. After this, we can discover descriptions for neurons by finding commonality or mutual information between the two models. It's not hard to see why this is important. Being able to generate descriptions accurate descriptions of regions of an image has massive potential, especially if we can imply things like the intent of a person in an image. Imagine how useful it would be if a self-driving car could learn about the intention of someone crossing the road. They're trying to scoop up a baby from traffic versus just trying to jaywalk. The use cases are endless. All right, this last story is pretty dramatic, so hang in there with me. Deepmind has created an agent that can code, which is better than the average human coder. And they proved this by competing in a coding competition. Okay, so real quick, the BBC says that this means it's better than the average human coder. I'm going to digress a bit. It means it's better than the typical human coder, or the median human coder, unless you believe that all the people that competed in the competition are perfectly normally distributed with respect to competence, which would be, I don't know, maybe that's true, but probably not. So let's say it's better than the typical human coder. Very good. Technical gripe over. Anyway, I'm not really a fan of these sorts of fuzzy accomplishments for two reasons. The first one is the sample size is just really small. There were 5,000 coders, but there was only one competition and only one Deepmind bot. Even if there were a lot of questions, who is to say that the bot didn't just get lucky with their selection? And also, it's entirely possible the bot did very well on a subset of these questions because of similar ones in their data set and totally missed a large subset where it provided completely nonsensical answers. This may be good by the competition standards, but it's pretty far away from good in a human sort of way. The second reason I have is that it's just not very good for performance as an actual developer. As someone who has worked in software for a while now, this isn't really representative of the tasks developers perform, which often involve a lot of abstract thinking and also a lot of awareness of the context the application is operating in. Still, this is remarkable. I think it's tempting to get caught up in all the news articles that are constantly flooding into us about how AI is beating a human at some highly specific benchmark. But we have to step back and consider how remarkable it is that these machines work at all and that they're able to do high-skilled labor like coding. Anyway, that's all the news for this week. Keep learning.